Last time I checked, operations usually doesn't like release all the code all at once and change everything once a year. If you do, ow, I'm sorry, that sounds rough. So operations is a really good fit for this sort of approach where you're constantly pulling in changes, validating, making sure they work, and then going live. So let's actually keep ahead with my slides instead of me going really far ahead. So continuous integration is terribly powerful for this sort of approach where, let's say you make a change. You write your test, whatever, and then you push it into some sort of CI pipeline. Maybe you submit a pull request and use Travis CI. Maybe you use GitLab and use a merge request or something like that, and so forth. Instead of directly merging things in, that change goes through some sort of validation first. It gets tested, it gets linted or something like that. Like, you know that one coworker that either you like spaces and they like tabs or vice versa, and they constantly do what you don't want them to? This is how you stop it. No more. So as part of your process, you do basic unit testing or some sort of acceptance testing or something like that. You do linting, and if Rob keeps using hard tabs, then you DOS his box and reject the commit or something like that. But you have a process where you can say, it is part of your core workflow of, you cannot bypass it, it is not, you can't forget to do it, you can't accidentally merge things in. Like, this is a core part of your workflow where you have guarantees that, I mean, if it passes CI, you can merge it. So this is actually really cool because you can be like, I don't know, let's see if it works. It'll pass CI if it does. Oh, that failed horribly. It's kind of the throw it against the wall and see what sticks approach. But this is really powerful. Now you don't have to obsess about doing everything just right the first time. It's actually a lot of fun. When I started in development, I found out how much freedom this actually gave us because, I mean, I could try more things. I could be experimental. I could take a lot of risks, and it was okay. This also gives you another advantage of, yeah, this always earns me brownie points. Extra brownie points if someone remembers the alt text for this one. But so, I'm sorry? Okay. I would be deeply, deeply impressed if you could. But so as part of this process, like, as I've been kind of driving this point, or driving towards this point, operations in a traditional go and set it up and do this manual labor process, this is going to go away. It is given by the fact that we've been automating everything in our society for the last 500 years or so. We're all going to be developers at some point, or pretty close to it. So we're going to be writing code, we're going to be making changes, and so you know that feeling when you're trying to work on something and like you make a change and you wait 5 minutes and it fails and you make a change and you wait 5 minutes. It is a horrible process when you're constantly being interrupted. And so you want to make sure that you can actually get really good feedback really quickly about what's going on, and CI can give you this. Basically, instead of like deploying code right away, you can do all sorts of validation up front. Like, once again, linting is very quick. Doing basic unit testing is very quick. Standing up in maybe a cluster of VMs will take a while, but you can layer things incrementally so that you can get feedback as quickly as possible. You catch as many failures as quickly as you can. And so using a process like that where you layer these tests using CI, your cycle time between testing, like making a change and testing it out, can be seconds instead of minutes or hours. I saw this on Twitter a while ago and I had to slip it in. So fun fact, Jenkins actually traditionally has blue as the successful value. This apparently comes from, I believe it was Japan, where streetlights used to be blue, turned to green for some reason. But yeah, so I was talking about having some sort of testing system and having, like, if you have a separate monitoring system and a separate testing system, you can get this lovely thing where, yeah, Jenkins is totally happy. Like, whatever tests you did there are great. And Nagios is crashing and burning, and your infrastructure is rolling over. So, oh, I'm so happy to see that, by the way. Cool, I'm not completely running out of time. All right. Unfortunately, I totally lost my train of thought. Oh, no, totally fine. No, I have, like, the attention span of, like, a small, young squirrel. So if you take this approach of your CI is the way that you get things done, and the same things are being used for your monitoring, you get to this lovely state where I will actually phrase this in an inflammatory manner. You can't work if shit's broken. This is really good because let's say the server over here is failing and like you should fix it, but you don't really want to. In a lot of development practices, the build must always be green. You must. Wait, Felix? Hi! I recognized you. Like I said, I have no attention span. You didn't believe me, did you? So with continuous integration in this sort of workflow, the build must stay green. If something goes red, you cannot merge new changes. You cannot add things on top of it. You have to fix it right then and there. This keeps you accountable. It can be painful when it's like this stupid server that Bob will not attend to, and he's breaking your important work, but it means that Bob better get his shit together, or his laptop is going to be like put in like a block of ice or something like this. But it is a good thing to make sure you keep on top of your system. Show of hands, how many questions do we have right now? Because I can keep rambling. Questions? I'm sorry? Hats? Hat. I'm sorry? Hands, hands. Oh, okay. I am slightly deaf, so bear with me. Okay, cool. That means I get to slip in my Benedict Cumberbatch reference. So the last thing I'm going to ramble on is basically how like things will crash and burn. You will miss something. You will write some code. You'll have tests, and everything will work fine. And like maybe it's 1 out of every 10 requests or something like that. But you will slip in subtle problems into your environment, and you're going to have to go through and debug it. Like this is a common thing. But I found that we don't do a great job of stressing like how to effectively like work through problems like this. So this section is completely like. I don't have any neat code snippets to show you. I don't have things like this because technical solutions are a lot of fun. I mean, you got to write greenfield code and you got to like solve a problem your way, and it makes for a great presentation. And if you solve a social problem with a technical solution, you're probably exacerbating the problem and hiding it. I've seen this too frequently. Shotgun debugging. Thing goes down. Why did it go down? I don't know. It could be this, this, and this. Let's change them all. Done it many times. And so maybe like the only thing worse than something breaking and you not knowing why is something now working and you not knowing why, because you don't know what went right. It is a scary situation to be in. And so it's, yeah, avoid that. Sherlocking. I've also seen this one where it's like, okay, well, this thing is going down, or the service has gone down. Let's think about everything that happened. Think about it really hard, and we're going to make some deductions. So first off, none of you are Sherlock, and none of you are dreamy enough to be Sherlock. I'm sorry, but none of you are Benedict Cumberbatch. So in this sort of environment, I mean, if something goes wrong, how much can you reduce this problem down? I mean, how many things can you pull out of the equation? How much can you simplify a problem and get it just down to the core issue? Probably when you like file a bug report on some sort of project, like you're going to see some devs saying, well, can you reproduce this, and what's the minimal reproducible case? It makes our lives so much easier. I mean, when you can say, here is just enough to reproduce this, and it works great in many environments too. In operations, we have so many moving parts. I mean, if you've got a network issue, I mean, maybe it's the cable, maybe it is the routing protocol, maybe it is spanning tree protocol. So really, figure out how much you can reduce the problem and simplify things. And in the same manner of, once again, change one thing at a time, make incremental progress, figure out what you can deduce from the environment. How are you doing on time? We've got 10 minutes? Okay. Anyone want to hear a story about how everything's terrible? Okay. Heartbleed. That was fun, huh? Everything really is terrible. So as part of the Heartbleed remediation, so there's this thing that I'm not sure many people have heard of it. It's called Azure, Microsoft Azure. It's a hipster thing. And there's this also thing that's called, what is it? Ubuntu. Yeah, that's it, Ubuntu. Ubuntu. So one of the things we did at Puppet Labs is we actually built a bunch of VMs that ran on Ubuntu on Microsoft Azure. Heartbleed came out, and everybody's like, oh my god, we now have to do Heartbleed remediation, update OpenSSL, and everything like that. And I think Canonical is partially at fault for this. So they're building these VMs. And so we have one environment that works. This is before Heartbleed is announced, um, and it works. Things are great. We start doing Heartbleed remediation. We bring up a new environment with the updated canonical box. Hostname resolution breaks. That's strange. I mean, literally, the machine can no longer resolve its own hostname, or it gets like a mangled hostname. And it's like, okay, well, what changed? Well, they actually have the same packages for like, it was ISC, DHCP client, same package. Okay, well, I mean, if it's the same package, I mean, what's happening on the actual wire? So, bust out TCP dump and start sniffing DHCP client, packets. There's a really neat feature, I only found out this is just in Ubuntu, where if you say, like, in the DHCP CD client config, there is, send hostname and then brackets hostname. On the newer machine, that string was literally being sent. On the old machine, it was actually the hostname being inferred. But once again, like, why is this happening? It is the same package on both ones. Like, it is the same package number and things like that. MD5 in the binary, different results. First rule, if you ever rebuild a package with the same version number and change something, I will find you and I will down. This was seriously like a good 2 weeks of work, and at the same time, we're trying to fix it. Oh, God, just bump the version number. It turns out that when they were working on this, this is also the fun thing, too. They also shipped a different configure, like, same package number, but a different binary and a different configuration. Even more fun, the new configuration they pulled in was for the wrong version. So once again, my God, just bump the version number. Turns out what happened is with the rebuilt version, they forgot to apply a patch. So in this sort of things, it is an iterative process of how, like, this should not have happened, and it was bizarre, but it's the sort of like, how can we systematically prove or disprove what is going on? So, anyhow, I thought this was kind of cute. All right, I think I'm pretty low on time, which is awesome because, questions? I'm sorry? Configuration management. Yes, that's it, configuration management. I've always wanted to do this is just like sit down in the front row and just talk to someone directly. Hi. Is this weird yet? Is this weird? Well, a little bit? Yeah. Well, it's things like, how does a developer work in the manner of like, how do we do change management? Like, or I've seen such a drastic change in like how I and my colleagues wrote code and version things and like worked with each other and did things like that. This may have been for the fact that we were a tiny startup with like 3 guys. When I started, it was Zach Leslie, Ben Hughes, and I. And our manager, we saw him like once every 6 weeks. So it was kind of benevolent anarchy. But I mean, we did not have these refined processes. We did not use CI effectively. You've seen my commit messages. We did not have a very good way of testing things. It was kind of I hope it works, and we might write some tests after it crashes and burns. And I never thought about applying like test-driven development and things like that. Reality is, like, we're all going to be developers in some manner. Automation is is changing everything, so it's also a very exciting title. So it's a little bit clickbaity. All right. Yes. Git revert dash m, oh God, why, and git push. There are a couple of ways. I've done some approaches. How we handle rollbacks, thank you. So I've seen it done a couple of ways. One approach where you basically have, let's say you have some sort of like clustered service or some sort of like multi-node monstrosity that consumes souls or something like that. 2 versions. As you do a rollout, you rotate them out via load balancer or something like that. When what crashes and burns, swap them back. If it's something smaller, hopefully you didn't change too much, then you can revert, just undo your changes and then run the same configurations. That is a tricky question, and there's things like Nixos that have some very interesting approaches to that, but rollback is inherently hard because you cannot unmake things, as far as I know. It depends, which is an extremely wishy-washy answer, but that's what I've got. Anything else? Yes?
Of those test actual examples, how far does it go testing? I have a specific example.
Mhm.
A specific case, it's a middleware, Java middleware ignore.
Mhm.
You have three possibilities of failing. The first is syntax error in the configuration file.
Mhm.
It fails directly.
Mhm.
Then no syntax error, but the thing starts and then
Mhm.
crashes because we
Mhm.
some bad file permissions.
Mhm.
And then the thing starts and runs
Mhm.
for a certain amount of
Mhm.
time, and then it crashes in
Mhm.
specific input.
Mhm. So the question that was asked is, how do you actually test things, or what do you test? Is that a good summarization? And so yeah, different failure modes. The biggest thing is when you're doing testing, test the desired, like the interface or the stuff that you care about. Like with the Apache example, I could have totally skipped the service running. I mean, I could have just said, make sure the port's running and possibly grab a web page and make sure it works. So a couple failure cases mentioned. You've got a configuration file syntax error. Apache will not start. That's great. Your port will not be open. Configuration is correct, but like the server won't start. Same thing. Port will not be open. For the case where you crash on a certain input, and we'll keep running your tests. But that's for a long or a. I would say let's call that a Heisen bug, where it may or may not happen. But I mean, there's not a lot you can do for something you don't have a guaranteed crash for, but active monitoring in that regard. But that's a good thing to mention is when you're doing testing, test the stuff you care about. Do not test the implementation. The service example was a little bit contrived. It's kind of cute, but you do have the aspect of it doesn't matter, because if the port is not open, well, I could rant on this a little bit more, but basically test the behavior you care about, not the exact implementation. Because like once again, if you switch to Nginx, your tests are gonna crash and burn, but everything could be working.
In this specific case, the configuration file is XML with C data and JavaScript evaluated at runtime. So this is the configuration you do. You modify this code.
It was what? So JavaScript and XML. Did I hear that right? Would you like a hug? I mean, it's really like. I don't want to give my feedback, but I will give you a hug later. In some manner, like, test the contents of the file and basically do some sort of like, is this React or something?
It's a middleware called Shibboleth.
Okay. Effectively, whatever manner you would do to like. Do you have a way of actually just like doing that parse without actually changing anything?
I tested manually when I touched this part of the configuration file.
Run a command and make sure the output is like 0 or something like that.
It's kind of a discipline.
We can talk more about a specific case later, but in the same manner too, I mean, you could say stand up the service, like on a test environment, stand up the service. If it crashes and burns, then somebody made a whoopsie. I've got like 2 minutes, 1 minute left. One? Okay. Really quick question. What do we got? RSpec Nagios formatter. So it is with RSpec you can say that when I run a test, if it fails, give me an F. If it passes, give me a dot. There's a test formatter called NyanCat formatter, which is awesome. Like it will give you a NyanCat when it's running. It's great. And in the same manner with the RSpec Nagios formatter, it just runs tests and formats out accordingly. All right. Let's just cut it off now. All right. Thank you.